Fedorov Avtomat, 1916. Before anyone knew what to call it, one Russian officer had already built it. Vladimir Fedorov was a captain in the Imperial Russian Army when he designed the Avtomat in 1916, a select-fire, detachable magazine rifle chambered for the Japanese 6.5 by 50 mm Arisaka cartridge. It was lighter than a rifle, more powerful than a pistol. It fired in full auto. It had a 25-round magazine. Modern firearms historians still argue about whether the Fedorov Avtomat was the world's first assault rifle. The argument is technical and largely semantic. What isn't arguable is this. In 1916, when every other army in the world was still deciding between bolt-action rifles and water-cooled machine guns, one Russian engineer had arrived at the essential formula. Intermediate power, automatic capability, one man, one weapon, more firepower than anyone around him had. Here's why the Arisaka cartridge matters. Fedorov didn't choose Japanese ammunition because he admired Japanese engineering. He chose it because Russia was buying Arisaka rifles from Japan and stockpiling their ammunition. The cartridge was available. More critically, it was lighter and generated less recoil than the standard Russian 7.62x54R, meaning the Avtomat could actually be controlled during automatic fire. Full-power Russian rifle rounds in a weapon this size would have been unmanageable. Fedorov understood the relationship between cartridge energy and usable firepower before any army's official doctrine acknowledged it existed. Only about 3,200 Fedorov Avtomats were ever produced. They saw service in World War I, the Russian Civil War, and, dragged out of storage, in the 1940 Winter War against Finland. The last time Russian soldiers carried Fedorov's century-old design into battle, the PPSH-41 didn't yet exist. The idea survived everything. The weapon's direct intellectual descendants, Simonov's AVS-36, Tokarev's SVT-40, eventually Kalashnikov's AK-47, all drew on what Fedorov had established about the relationship between cartridge selection, controlled automatic fire, and individual soldier capability. He built the concept before the concept had a name. The Germans, characteristically, built a worse version first. Browning Automatic Rifle, M1918A2, 30 minutes. That was the estimated average combat life expectancy of a BAR gunner in World War II. Not because the weapon failed, because the enemy prioritized killing the man who carried it above almost every other target in the squad. That prioritization was its own verdict on the weapon's effectiveness. John Moses Browning designed the M1918 in 1917, presenting the prototype to Congress before delivering it to the American Expeditionary Forces in France in September 1918, 6 weeks before the armistice. First deployed by the 79th Division on September 13th of that year, it arrived just barely in time to prove itself before the war ended. The BAR fired .30-06 Springfield, the same cartridge as the M1903 Springfield rifle, the M1 Garand, and the Browning M1919 machine gun. This logistics advantage was the foundation of American infantry doctrine for 3 decades. One caliber, all weapons. The BAR man in a squad carried the same ammunition as every rifleman around him. When his 20-round magazine emptied, any of the 12 men in his squad could hand him more. At 16 to 19 pounds, depending on variant, the BAR occupied an awkward tactical category. Too heavy to be a rifle, too light and mobile to be a machine gun. American doctrine eventually stopped trying to classify it and simply made it the automatic backbone of the infantry squad. 1 BAR per 12-man unit, every unit from Guadalcanal to Normandy to Okinawa. The combat reality was that the BAR was often used the way the STG-44 would later want to be used. Individual soldiers carrying it on the move, firing bursts from the shoulder, providing automatic suppression at ranges where submachine guns couldn't reach and machine guns couldn't maneuver. German soldiers who encountered BAR-equipped American squads repeatedly noted in after-action reports that they assumed each squad contained a dedicated machine gun position. They were wrong. It was one man with one weapon. The Marine Corps took this further. By 1945, they had reorganized their squads around 3 4-man fire teams, each with its own BAR, 3 per squad. Combat experience in the Pacific had proved that the 12-man squad with 1 BAR was the wrong answer. 3 BARs per squad was, by multiple commanders' accounts, barely sufficient. Every post-war analysis of American infantry effectiveness in World War II eventually arrives at the same sentence. The BAR was the backbone of the infantry squad. The Germans said it. The Japanese said it. The American commanders who survived the war said it. The average combat life expectancy of 30 minutes was their clearest statement of respect. But automatic fire from a full-power cartridge was only one approach. Germany was chasing something different. AVS-36 SVT-40, the Soviet semi-automatics. The Soviet Union tried to replace the bolt-action rifle before anyone else did, and paid for the attempt in blood. The AVS-36, designed by Sergei Semenov, accepted for service in 1936, was a selective-fire automatic rifle, chambered for the full-power 7.62 by 54R cartridge. It was issued to Soviet infantry before the M1 Garand reached American hands in quantity. It was built 6 years before Germany's STG-44 existed on paper. It was also a disaster. Full-power automatic fire from an individual rifle produced recoil that no human being could manage effectively, a muzzle blast that ruptured eardrums at close range, and mechanical stresses that broke firing pins with depressing regularity. The AVS-36 was withdrawn from service in 1941. Of the 65,800 produced, most were quietly removed from inventory and replaced. Fedor Tokarev, designer of the TT-33 pistol, had a better answer. The SVT-40, adopted in 1940 as a semi-automatic only, fired the same cartridge, but removed the automatic selector entirely. The logic was sound. Semi-automatic fire from a full-power round was manageable. Automatic fire was not. Accept the limitation. Build the achievable weapon. At its best, the SVT-40 gave Soviet infantry a semi-automatic rifle 2 years before most of their enemies had one. The sniper variant, fitted with a PU 3.5x scope, was used by Lyudmila Pavlichenko, credited with 309 confirmed kills and known to history as Lady Death. Finland captured SVT-40s during the Winter War and kept them in service until 1958. Germany captured them during Barbarossa, designated them the Selbstladegewehr 259R, and carried them until 1943. More significantly, German engineers studied the SVT-40's gas system so carefully that when they redesigned their own Gewehr 41 semi-automatic rifle into the Gewehr 43, they simply copied the Soviet system. The SVT-40's gas piston operating system, short stroke above the barrel, became the direct mechanical ancestor of the FN-FAL, which would arm NATO for 40 years. The weapon's failure was not engineering, it was maintenance. The SVT-40 required regular adjustment of its gas system, specifically the regulator that controlled how much gas cycled the action. Soldiers who maintained it properly reported excellent reliability. Soldiers who didn't, and in the chaos of 1941-42, most couldn't, experienced constant malfunctions. By the war's end, Soviet industrial priority had shifted to the PPSH-41 submachine gun and the Mosin-Nagant bolt action. Only 1.6 million SVT-40s were produced before January 1945. The design was sound. The army that carried it was fighting for survival. Sometimes the two facts don't align. America solved the maintenance problem differently. M1 Garand. General George Patton called it the greatest battle implement ever devised. That sentence has been quoted so many times that it risks losing meaning. Here's what restores it. Every other major army in World War II equipped their standard infantrymen with bolt-action rifles. Germany, Japan, Britain, the Soviet Union at scale, Italy. All of them sent men into battle with weapons that required manual operation between every shot. Work the bolt, chamber the round, aim again, fire. In the hands of a trained soldier, 15 rounds per minute was excellent. 20 was exceptional. The M1 Garand fired 40 to 50 accurate shots per minute from the shoulder in the hands of an average soldier. No bolt operation, no disruption to sight picture between rounds. Point, pull, fire 8 times, reload, repeat. That difference, measured in rounds per minute per rifleman, was the decisive tactical advantage of the American infantrymen in every theater of the war. John C. Garand, a Canadian-born civilian engineer at the Springfield Armory, spent 15 years developing the M1, a gas-operated rotating bolt system fed from an 8-round en-bloc clip, a metal clip that loaded with the rounds and ejected automatically when the last round fired, producing the distinctive metallic ping that every World War II film has used to indicate an empty rifle ever since. The .30-06 Springfield cartridge it fired was the same round used in the BAR and the Browning machine guns. Every American infantryman, BAR gunner, and machine gun team carried the same ammunition. Supply, training, and logistics were unified around a single cartridge. The Germans first encountered the Garand in North Africa in 1943. Their after-action reports were consistent. American infantry put out a volume of semi-automatic fire that German bolt-action units struggled to match. The Wehrmacht began developing their own semi-automatic rifle, the Gewehr 43, partly in response. They equipped 19 per infantry company. American infantry carried Garands as the universal standard issue for every rifleman. 5.5 million M1 Garands were produced. They served through World War II, Korea, and into the early stages of Vietnam. In 1957, when American infantry finally transitioned to the M14, essentially an improved select-fire Garand, the basic mechanical concept Garand had established in 1936 continued without interruption. The M1's en-bloc clip design was its most debated feature. Unlike the SVT-40 or STG-44, the clip couldn't be topped off with partial rounds mid-magazine. Once loaded, all 8 rounds had to be expended before the clip could be replaced. In combat, disciplined trigger control managed this limitation. In the hedgerows of Normandy, in the jungles of Guadalcanal, in the frozen hills of Korea, American soldiers managed it. The greatest battle implement ever devised. Patton was not given to understatement, and he had considerable data to work with. But one weapon the Germans built threatened to make every semi-automatic rifle in the world obsolete before the war ended. FG-42, Fallschirmjägergewehr 42. Crete changed everything. On May 20, 1941, the German Fallschirmjäger, paratroopers, jumped into the island of Crete against British, Commonwealth, and Greek defenders. German doctrine at the time required paratroopers to jump with only their sidearms. Their rifles, machine guns, and heavier weapons were dropped separately in containers. The containers landed where they landed. The paratroopers landed where they landed. For the agonizing minutes between touchdown and weapon retrieval, German paratroopers had pistols. British soldiers had Lee-Enfield rifles at 500-meter range. The battle for Crete cost Germany over 4,000 killed and more than 2,000 wounded, catastrophic losses for an elite unit. Hitler banned large-scale airborne operations afterward. The Fallschirmjäger, drawing their own conclusions, demanded a new weapon, one rifle that could replace every specialized weapon in their kit. Semi-automatic fire at range when needed, full automatic when needed, compact enough to jump with, light enough to carry, powerful enough to answer Lee-Enfield fire at 300 meters. The FG-42 delivered all of it. Louis Stang of Rheinmetall designed the FG-42 around the standard 7.92 by 57 mm Mauser rifle cartridge, the full power round that every Wehrmacht rifle fired. A 20-round side-mounted magazine, selective fire, semi-automatic from a closed bolt for accuracy, fully automatic from an open bolt for sustained fire, a bipod for the prone position, a spike bayonet. The entire weapon weighed just over 9 pounds, lighter than the BAR, firing a more powerful round, with both fire modes in one package. The technical innovations were extraordinary. The straight-line stock design reduced muzzle rise during automatic fire more effectively than any contemporary weapon, a concept so sound that American engineers copied it directly for the M60 machine gun developed in the 1950s. The inline recoil configuration became standard for virtually every military rifle designed after 1950. Only 7,000 FG-42s of all variants were ever produced. The weapon was expensive, machining intensive, and demand for raw materials in 1943 Germany was brutal. The Fallschirmjäger carried them on Monte Cassino, at Anzio, in the Ardennes. Soldiers who used them in combat reported extraordinary effectiveness at ranges where submachine guns failed and standard rifles required bolt operation between shots. The FG-42 arrived too late and was built in too few numbers to change anything strategically. but as a technical statement about what automatic fire from a full-power rifle cartridge could look like when engineered correctly, it established a design philosophy that outlasted the war by 70 years. Germany was learning lessons about infantry firepower from every front. One lesson came from the East, where Soviet PPSH-41s were outgunning Kar 98K bolt actions at close range. That lesson produced something the world had never seen: MKB-42, MP-43, the father of the STG-44. Hitler banned it. Then he approved it. Then he banned it again. Then a general lied to his face about what it was. Then Hitler named it himself and took credit for the concept. The political history of the weapon that became the STG-44 is almost as interesting as the weapon. By 1941, German infantry on the Eastern Front had identified a tactical problem that their high command refused to acknowledge. Most infantry combat was happening at ranges between 100 and 400 meters, far shorter than the 800-meter range for which the Kar 98K bolt action had been designed. The Kar 98K was excessive. The MP-40 submachine gun was insufficient. Something in between was needed. Hugo Schmeisser at the Haenel factory and the engineers at Walther both began development of what they called the Maschinenkarabiner 42, machine carbine, chambered for the new 7.92 by 33 mm Kurz cartridge. Kurz means short, the same caliber bullet as the standard Mauser rifle round, but in a shorter case with less powder. Approximately half the energy of the full-power cartridge, but twice the energy of 9mm pistol ammunition. Controllable in automatic fire. Effective beyond 300 meters. Hitler prohibited the program. He believed infantry needed long-range rifle capability and submachine guns, not something between them. The Wehrmacht circumvented him. They redesignated the weapon as the MP-43, Maschinenpistol 43, or machine pistol, disguising it as a submachine gun upgrade to avoid triggering Hitler's ban on new rifle development. Thousands were issued to Waffen-SS and then army units on the Eastern Front under the false designation. The deception was eventually discovered. Hitler was initially furious. Then, in July 1944, at a meeting of senior commanders discussing Eastern Front needs, a general demanded, "More of these new rifles!" in Hitler's presence. Hitler reportedly turned to the general and asked what new rifle he meant. A demonstration was arranged. Hitler saw the weapon perform. He was impressed. He renamed it the Sturmgewehr 44, assault rifle, model 1944. He coined the term himself. The concept he had suppressed for years, he now claimed as his own propaganda triumph. The MKB-42 to MP-43 to STG-44 lineage is the documented birth of the assault rifle as a weapon category. Everything that followed, the AK-47, the M16, the assault rifles carried by every infantry force on Earth in 2026, traces its conceptual DNA to what Hugo Schmeisser and the Haenel design team built in 1942 while trying to avoid Hitler's attention. But the final version was even more than any of its predecessors. STG-44, Sturmgewehr 44, one name, given by the man who had tried to kill the program that created it. The Sturmgewehr 44 was the first assault rifle to enter large-scale production and widespread combat deployment in history. That sentence is still true regardless of which historians are arguing about the Fedorov Avtomat's classification. The STG-44 was purpose-built, mass-produced, and issued in numbers that changed tactical doctrine during active combat. No previous weapon can make all three of those claims simultaneously. The 7.92 by 33 mm Kurz cartridge it fired was the engineering breakthrough. 200 meters of effective range exceeded what any submachine gun could offer. Its muzzle velocity, 685 meters per second, was lower than the Kar 98K's 760, but far above the MP-40's 365. The intermediate round hit harder than pistol calibers at range while remaining manageable in automatic fire. The curved 30-round magazine it required became the visual signature of every assault rifle that followed. A gas-operated selective fire weapon, the STG-44 weighed just over 10 pounds loaded. Rate of fire, 500 rounds per minute. Effective range in semi-automatic, 300 meters. In automatic, 150 meters of suppressive capability. The first production units were issued to Waffen-SS units in October 1943 on the Eastern Front, specifically to counter Soviet infantry equipped with PPSH-41s. Soldiers who received them immediately recognized the tactical shift. German soldiers on the Eastern Front were explicit in their after-action reports. The STG-44 allowed a single rifleman to match the close-range volume of fire from Soviet submachine gun units, while maintaining effective capability at ranges where PPSH-41s became useless. The weapon solved both problems simultaneously. For the first time, German infantry could suppress at close range and engage at medium range with the same weapon. When samples of the STG-44 reached American intelligence officers, their assessment was unusually candid. Nothing in the American inventory performed this combination of functions. The M1 Garand was more accurate at range. The Thompson and M3 grease gun were inferior at range. Nothing was both. Only 425,977 STG-44s were produced before the war ended. Production constraints, steel shortages, bombing of manufacturing facilities, the general collapse of German industrial capacity prevented the numbers that might have mattered. Wehrmacht units that received them prized them. Units that didn't envied those that did. After the war, the Soviets examined captured examples extensively. Mikhail Kalashnikov, who had been wounded at the Battle of Bryansk in 1941 and spent his recovery designing weapons, acknowledged studying the STG-44 concept. The AK-47 he produced in 1947 was mechanically different, but conceptually identical. Intermediate cartridge, curved magazine, selective fire, controllable, simple enough for mass production and distribution to infantry of any training level. The AK-47 became the most produced firearm in human history. The STG-44 became the reason it existed, but the war ended before Germany could field it in numbers. And in the final calculation of what actually changed the war, rather than what changed history, there was still one weapon that did both. M1 carbine, M2 carbine. 5.5 million rifles for the men who weren't supposed to need them. The M1 carbine was created for a specific military problem. Support troops, artillerymen, radiomen, medics, officers, truck drivers. The entire category of soldiers who needed to carry a weapon but couldn't carry a full-size M1 Garand without it interfering with their actual job. The Garand weighed 9.5 pounds. At 43 inches, it caught on everything in vehicles, tents, and cramped command posts. The solution was a new weapon, a new cartridge, and a new industrial story. David Marshall Carbine Williams, who had developed his gas piston design while serving a prison sentence at a North Carolina work farm, and who was later portrayed by Jimmy Stewart in a Hollywood film, contributed the short-stroke piston mechanism that became the M1 carbine's operating system. Winchester's engineering team assembled the weapon from components borrowed from the Garand operating rod, a Winchester Model 1905 trigger group, and Williams' gas system. The first workable prototype was cobbled together in 13 days. The Army accepted it in September 1941. The .30 carbine cartridge was essentially a rimless version of an obsolete pistol round. 110 grains, approximately 1,990 feet per second at the muzzle. More powerful than 9mm pistol ammunition. Significantly less powerful than .30-06. Light, manageable, accurate enough to 150 meters in the hands of soldiers who had limited rifle training. At 5.5 pounds and 35 inches, the M1 carbine was nearly half the weight of the Garand and several inches shorter. Paratroopers carried a folding stock variant, the M1A1, with the stock folded flat for the jump. Officers carried it as a primary weapon. Tank crews carried it as backup. Support troops discovered that the weapon designed for the people behind the lines was more than adequate for the people who ended up at the front, whether they were supposed to be there or not. Then, in late 1944, the M2 carbine arrived. A simple selector switch. Semi-automatic or fully automatic. 30-round magazine in place of the 15-round original. Rate of fire, 750 rounds per minute. The M2 carbine is never discussed in the same breath as the STG-44. Its cartridge was underpowered by serious combat standards. Its range was limited. Its stopping power against determined enemies in the Pacific, documented in Marine Corps after-action reports from Okinawa, was questioned throughout the campaign. But the M2 carbine was, by the strict technical definition, the most widely deployed select-fire infantry weapon America produced in World War II. Over 500,000 M2 conversions were made. Every branch carried them. The Korean War saw M2 carbines issued in numbers that exceeded any submachine gun. American infantry officers of that conflict ranked it as a practical squad automatic weapon for close-range engagements, something the Army hadn't formally requested, but discovered it needed. The M1 and M2 carbine story is the story of a weapon designed as a compromise that became essential. In the scramble of infantry combat, the men who were issued carbines because the Army didn't think they'd need real weapons found that the weapon was exactly what real combat demanded. 8 weapons. One evolving answer to the same question. How does a single soldier carry enough firepower to decide the outcome of the next 30 seconds? The Fedorov asked it first. The BAR answered with raw power. The SVT-40 answered with semi-automatic volume. The Garand answered with precision. The FG-42 answered with engineering genius that nobody could afford to produce. The MKB-42 and MP-43 answered with political deception. The STG-44 answered by naming the entire category. The M2 carbine answered for the people who were never supposed to be there. Every assault rifle and infantry weapon built after 1945 is a response to something one of these 8 weapons proved possible. The modern soldier carries a weapon shaped by this war. Not metaphorically, mechanically. The gas piston above the barrel, the curved magazine, the intermediate cartridge, the selective fire, the detachable magazine, the straight-line stock. All of it was figured out between 1939 and 1945. All of it, by men who needed it immediately and had no time to wait for perfection. Necessity didn't invent the assault rifle. Survival did.